Welcome to the DIY Honda Garage channel. The DTC P0450 refers to a fault in the fuel tank pressure sensor, indicating that its output voltage has gone beyond specified limits. The Powertrain Control Module, PCM, monitors various sensor outputs, including that of the fuel tank pressure sensor, and determines abnormalities based on the input it receives. When the sensor output voltage is either less than 0.20 volts or more than 3.61 volts, the PCM is triggered to store the DTC P0450. The fuel tank pressure sensor plays a vital role in managing the vehicle's emission system and is generally located near the fuel tank or within it. By constantly monitoring the vapor pressure inside the fuel tank, this sensor helps in maintaining optimal performance of the evaporative emission control system. The sensor's proper functioning is crucial to prevent fuel evaporation and ensure vehicle efficiency. The fuel tank pressure FTP sensor is a critical component that measures the vapor pressure in the fuel tank. This sensor, located close to the fuel tank, helps the Powertrain Control Module, PCM, manage fuel evaporation and ensures that emissions are controlled as per regulations. The PCM utilizes the sensor's input to monitor fuel system integrity and optimize engine performance. If the FTP sensor detects abnormal pressure values, it will lead to DTC P0450 being stored. The PCM is responsible for the overall health of the engine and needs accurate readings from components like the FTP sensor to function effectively. A faulty sensor or wiring issues can disrupt this flow of information, prompting the need for diagnostic checks. The possible causes for DTC P0450 generally include a faulty FTP sensor, issues within the FTP sensor circuit, or a malfunctioning PCM. A faulty FTP sensor can produce incorrect voltage readings, leading to the PCM detecting abnormalities. Circuit-related issues, such as broken wires or poor connections, can also affect sensor performance, resulting in voltage readings that trigger the error code. Lastly, if the PCM itself is malfunctioning due to internal errors or software issues, it may misinterpret the signals from the sensor. Each of these causes must be meticulously checked and confirmed during the troubleshooting process to effectively resolve the DTC. Symptoms that may occur when DTC P0450 is triggered include the illumination of the check engine light, decreased fuel efficiency, and potential emissions issues. The check engine light alerts the driver that there's an error in the vehicle's systems, often triggering immediate concern for performance. A faulty FTP sensor can lead to incorrect pressure readings, affecting the vehicle's fuel efficiency. A driver might notice the engine consuming more fuel than usual. Additionally, if the FTP sensor is malfunctioning, it may allow vapors to escape, potentially leading to emissions violations, which can have regulatory consequences. Drivers should be aware of these symptoms, as they might indicate both a performance and a compliance issue. In the first troubleshooting step for DTC P0450, begin by inserting the emergency fuel funnel into the fuel filler neck, which is conveniently stored in the trunk toolbox. This action is important to create a controlled environment for the subsequent steps. Next, turn the vehicle to the on mode, ensuring that all electrical systems are activated without starting the engine. Monitor the HDS, Honda Diagnostics system, for the FTP sensor voltage. If this voltage is recorded as less than 0.20 volts or greater than 3.61 volts, this confirms that the failure has been duplicated, providing a clear indication of the need for further diagnostics on the FTP sensor itself or associated circuits. After performing the first troubleshooting step, proceed to the second step by starting the vehicle's engine. It is crucial to hold the engine speed at 3,000 RPM without any load, meaning that the car should be in park or neutral. This action ensures the engine control unit, ECU, operates within a consistent range. Continue to monitor the HDS to check for the OBD status, specifically looking for the appearance of DTC P0450 during this process. This step helps confirm if the conditions triggering the DTC persist under a load situation, thereby providing deeper insight into whether the issue is with the FTP sensor or related components. The third troubleshooting step involves conducting a more detailed inspection of the FTP sensor itself. Begin this process by disconnecting the FTP sensor connector 3P, ensuring that the vehicle is in the off position for safety. Next, you'll perform a voltage inspection to determine if the sensor is functioning within normal parameters. The normal output voltage should be around 5.0 volts when the ignition is in the on position. If the voltage exceeds or falls below this range, it confirms an abnormal condition, indicating that the FTP sensor may need replacing or further inspection of its connections to assess for any wiring issues. In the fourth step, you will need to conduct thorough inspections of the related wiring to the FTP sensor and the powertrain control module, PCM. Disconnect the FTP sensor connector, 3P, alongside the PCM connector, A72P, for this process. Inspect each wire meticulously for signs of wear, corrosion, or disconnection, as these issues can contribute to abnormal readings. For normal circuit conditions, there should be less than 1 ohm of resistance in the VCC6, P-tank, and SG6 circuits. If there are resistances that exceed this threshold, it indicates a fault in the wiring or connections, necessitating repair or replacement before proceeding. The fifth troubleshooting step emphasizes verifying the integrity of the electrical circuits linked to the FTP sensor. Using the disconnected FTP sensor and PCM connectors, perform inspections to check for any signs of shorts or open circuits that may have occurred. Each circuit should display normal operational readings, and resistances exceeding set thresholds could indicate critical wiring issues. Following this inspection, it will be necessary to confirm that all circuit symptoms have been accounted for and no faults remain. If the tests confirm that the circuits are intact and functional, only then can you determine that the issue resides in another component, potentially the PCM itself. In the final troubleshooting step, you must conduct an inspection of the powertrain control module, PCM, if all other components and connections have checked out successfully. This step involves assessing the PCM for any internal malfunctions or software issues that might be affecting its ability to process input from the FTP sensor accurately. If the previous steps have ruled out the FTP sensor and related circuits as faulty, it's reasonable to conclude that the PCM could be at fault. Should you find incontrovertible evidence of PCM failure, a replacement may be warranted to restore vehicle functionality and performance standards. After completing all necessary repairs or replacements concerning DTC P0450, it's vital to conduct a final verification process to confirm that the issue has been successfully resolved. Initiate a test drive under varying conditions to allow the vehicle to run through its full operating parameters. During this test drive, keep a close eye on the system for any illumination of the check engine light or the presence of DTC P0450. Additionally, monitor the overall performance of the vehicle, including acceleration, fuel efficiency, and response to throttle inputs. If all observations confirm proper operation without the return of DTCs, the repairs can be deemed successful. This ensures that your vehicle operates within optimal performance levels and regulations. To prevent future occurrences of DTC P0450, it's essential to implement a routine maintenance schedule focusing on the FTP sensor and associated components. Regularly check the sensor and its wiring for wear or damage, ensuring that any issues are addressed promptly. Monitoring the entire fuel system, including its seals and connectors, will also help in maintaining optimal performance and preventing leaks or faults. Keeping connections clean and free from corrosion can significantly extend the lifespan of electronic components in the vehicle, minimizing unexpected failures. This proactive approach not only enhances vehicle efficiency, but also maintains compliance with emissions regulations. In conclusion, addressing DTC P0450 requires a clear understanding of the fuel tank pressure sensor's role in the Honda Accord's fuel management system. Following the structured troubleshooting steps enables technicians to accurately identify and rectify any fault while ensuring related components are functioning properly. Timely intervention and addressing underlying problems can prevent more significant issues down the line. Moreover, incorporating preventive maintenance practices aids in sustaining vehicle performance and mitigating future errors. By staying vigilant and informed about vehicle diagnostics, owners can ensure their Honda Accord remains reliable and compliant with emission standards. Please like and subscribe to the channel. See you next time.